I'm going to talk about how to do CIDR addressing and figure out what are the assignable IP addresses, what's the range, and what's the net mask. So first we're going to start with this example. We have a CIDR address of 152.2.136.0/26. And so the components of this is the network address, and this tells us how many bits are in the network part of the address. So remember, every IP address has a network part and a host part. So we're told that there are 26 bits for the network part. We have 32 bits total in an IP address. Minus 26 is 6 bits available for the host part. So 2 to the 6th is 64. So there are 64 possible IP addresses in this range. Now remember that there are always 2 IP addresses that are reserved. The first one is with the host part all zeros. That's the network address. Okay? The second one is with the host part all ones. That's the broadcast address. So if somebody sends to that, it goes to all of the hosts on that network. So we subtract 2 from there, and we end up with 62 assignable IP addresses. All right? Okay, now how do we figure out what the range of these addresses are? So the easiest way to do this is to look at what are the bits in this address. Okay? So if we have 6 bits in the host part is always in the rightmost part of the address. So this last octet is 8 bits long. 6 of them are part of the host part. So we really only need to write out the binary for this last octet. So 0 is 8 zeros. Now, one thing to remember is if your network part is less than 24, then you're going to have some host parts in this host bits in this part of the address. So don't think that just the last octet in the dotted decimal, that's where all the host parts live. That's not how CIDR works. CIDR is based on the particular number of bits. So if you have a CIDR address where the network part is less than 24, you're going to have to go farther in converting the IP address to binary to figure out where you need to make the difference to figure out the range. Okay, so this is the last octet, and so what we know is the first assignable IP address is with all of the host bits 0 except for the last one. Okay, so we have 6 host bits. Our host bits are these last 6. These 2 guys and all the rest of them are part of the network address. Okay, so if we make these all zeros except the last one, and these always stay the same, then this is going to be 152.2.136.1. Okay? Since 152.2.136, all of those bits are part of the network part, they never change. They always stay the same. So we're just looking at this last octet. So this is the first assignable IP address. Another easy way to do this is that you have the host address, which is all of the host bits 0. The first assignable IP address is all the host bits 0 except the last one. So the first assignable IP address is always going to be 1 plus the network address. So that's a trick. Sometimes the last assignable IP address can be a little bit tricky. In this case, it's not. So we bring down the network part of the address, and now we're going to put all of the host bits to be 1 except for the last one. Remember, all the host bits 1 is the broadcast address. Right, so the 152.2.136 stays the same, and so now we end up with 62. And so that's what this is. Okay. So the broadcast address in this case, you may be used to thinking of the broadcast address as 255 with all 8 bits being 1, but in this case, for this network, the broadcast address is 152.2.136.63, just the host bits being 1. Okay? So how do we figure out what the net mask is now? So the net mask is where we take all of the network bits, we make them be 1, and all of the host bits, and we make them be 0. All right? So 8 ones is 255. So we know that these 3 octets are all part of the network part. So then we have 255.255.255, right? And so now we need to figure out what the last octet's going to be. So for the net mask, the network parts are 1s, and the host parts are 0s. Okay? And so then this is 192. Okay? We have 128 plus 64. Right? So 255, 255, 255, 192 is the net mask. Okay? So this is the first assignable, this is the last assignable, and this is the net mask.